then I make sure to label everything. I'm being given that that's 280 degrees, therefore that little arc must be 80, and that angle must be 80. That's what I'm looking for. This is H. And I would just jot down that the reason I know what I'm doing on that problem is because I know that I'm looking at a central angle. Just a little phrase, a note, something to justify whatever I did. You're going to find that a majority of the circle questions boil down to that type of angle. What is that type of angle? Inscribe. And the rule for that is half of the arc. When I say half of the arc, I mean the intercepted arc, the trapped arc, the arc that's caught between the angle. We also have a central angle involved, and 68 is given for this angle. That makes this arc 68, and half of that is 34. You'll notice that there's no multiple choice here. This is a typical short answer question you might see on an SOL test. You have to put in the correct answer. It's either right or it's wrong. Anytime I see something like number 3 with secants, then I'm putting in brackets. This bracket is already taken care of. What do the brackets represent? What part of whoa? The W. What does W stand for? Whole. So if I want to put in an expression for the whole, in this case it would be 9, 5 plus 4. So for whoa, I have 9 times 4. That's the outer portion. And 12 times this little portion, which is what I'm looking for, so I'm going to call it X. 36 equals 12X. X equals 3. Choice F. Any questions on those first 3? And that was whoa. Once again, we have an inscribed angle. We know that that's half of its intercepted arc. So the rest of this is just thrown in there to confuse you a little bit. We're focused on just the inscribed angle, ABC. Number 5. I don't see a triangle. I do, but what I really see are 3 inscribed angles. Anytime I see some sort of polygon that's inscribed within the circle, I really see a bunch of inscribed angles. So I have to think of that rule, which is half of the arc. So even without looking at the question, I know that that 50 cuts off an arc of 100. That 60 cuts off an arc of 120. It is a triangle, so I should be able to figure out that that's 70 inside there out of 180. That leaves me 140 for that arc up there. What am I actually looking for? PR. Where's PR? Next page. Five, 12, X6. What's my little rule that we made up for a 2-chord segment situation? Cross multiply. when we actually do the proof of this, you will see that it truly is cross multiplication because it comes from a proportion. And C10. If I'm looking at this, they're telling me that this is a tangent. And by they, I mean the Virginia Department of Education. Let's label radius. And now I'm thinking of this rule. Radius and tangent always are perpendicular. So as soon as I saw this diagram, this was the method I chose. That's a right angle. I already know the 25, so this angle here, which is actually what I'm looking for, CBR, must be 65 degrees. There's other ways to do this. You've got an inscribed angle, which means that this arc must be 50. That's a semicircle, so we have 130 for this arc, and that angle is actually a chord tangent angle, and that's half of its intercepted arc, which would be 65. A couple different ways to get at the same answer. Number 8 has a tangent and a secant and a bunch of arcs and angles. What's the rule for a tangent secant angle and arc situation? What do I end up doing if I'm looking for this angle? Subtract arcs, divide by 2. What arcs? I need the arcs inside here. I don't have that one, but with a little bit of subtraction from 360, you should be able to get 180. So I'm dealing with this and this. 180 minus 70 divided by 2. 55. Number 9, more inscribed angles. I'm not even going to look at what's being asked for. The 50 cuts off an arc of 100. An arc of 140 is cut off by an angle of 70. It is a triangle, so I can figure out the remaining angle. And that cuts off an arc of 120. And it looks like I am looking for PQ, which is 120. A bunch of inscribed angles. Number 10 is a rule that we really didn't discuss, but intuitively you probably knew how to do it. If they're telling you that this is 106 degrees, raise your hand. Tell me what you did to figure out PS. And probably you just used the rule without even knowing it. What did you guys end up with?
I got it.
127 for over here. How did you get that?
That's probably gonna make stuff like
What's equivalent?
RPS.
All right. It creates some symmetry. Not only, the rule that we learned was that this, if it has a right angle, cuts this in half. Well, not only does it cut that in half, it cuts the arc in half. This is a diameter, so it cuts the whole circle in half. So we're going to have 53 degrees here, 53 degrees here. And if you have half a circle, that leaves 127 for that side. Number 11. Part of the reason why I show these problems is because this is what students got wrong the previous 2 years. Plot the center and 1 point that lies on the circle. Put a box around that. Integral coordinates. What does that mean? What word does integral look like? What is it derived from?
Integer.
Integer. Let's write that down. Does everybody know what an integer is? Actually, tell me what an integer is not. No decimals, no fractions. So you want to see this showing up. You want to see integral coordinates asked for. That means you don't have to deal with in between the actual intersections of these lines. You don't have to deal with fractions. You don't have to deal with decimals. So it's just telling you, give me an integer, whole number, or its opposite answer. Forget about the question for a second. If you have that equation, what would be the center? Does everybody have 0, 2 as their center? Let's find that. That's right here. If your diagram on the SOL has blue on it, can the computer see that? No. If you use the point tool and put that onto the graph, you haven't done anything yet. Blue is for you. If you do something in red, that's answered. How do you put a red dot on your diagram? What button do you have to click first? What's going to make sure that it's red? The pointer tool, the cursor tool, whatever you want to call it. The one that's furthest to the left will give you the red. According to the software, you've answered the question. There's something red on there. So is the question done? No, the computer thinks that it's done. So you got to make sure that you have put the required amount of points on here, because nobody's going to tell you, oh, you only have 1 point down. You still need one more point that actually lies on the circle. For that, we need the radius. What's the radius of this situation? 5. If we want integer coordinates or integral coordinates, you can only move vertically and horizontally to make sure that you get integer coordinates. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So any one of those would be okay. Don't put more than you need. How many do we need? We need a center and 1 point. That's going to give you all the points or a correct answer on the SOL. 2 red points. If it asks for 3 points or 1 point, make sure that you're answering the question correctly. As soon as the software sees red, it thinks you answered the question. What else do we need? Sometimes you might have to actually give the coordinates of the center or give the coordinates of a point that's on the circle. Just pay attention to direction. 13. You could always graph this if you wanted to, but there's no guarantee that these points will be vertical and horizontal to your center. So you're never quite sure if they're on the circle itself unless you figure out the equation. If circle W has a center of -4, 6 and a radius of 10, even if you didn't write the equation, let's write it now. We would square the radius. we would put the opposite of what we're seeing. We see -4, so I put +4. I see 6, so I put -6. To be absolutely sure that it lies on the circle, you substitute. Put those in. If you get a true statement, then they're actually part of the circle. If I put a 0 there and a 4 there, I will not get 100. If I put a 2 there and I put a 10 there, I will not get 100. If I put 4 right here and I put 0 right there, that's 8 squared plus -6 squared. What's that equal to? That's equal to 100. That's the only one that actually makes that a true statement. That's how you are absolutely sure that it lies on the circle. This one probably could have been done. Let's take a look. -4, 6. -4, 6. Oh, radius 10. There we go. No, this would have been best done by the exact procedure that I just put up here. Because 4, 0, right around here, so it wouldn't be on one of the horizontal or vertical situations that we talked about in the previous problem. If I see a problem like this, either in my head or on paper, I redraw it in a simpler way. I don't want to see all of this. I want to focus maybe on J to start. Here's J. What two arcs are intercepted by angle J? 120 and 30. So what I have in blue there, I put alone. Then what I might do is in red, maybe I'll focus on angle K. K cuts off what arc? 140. I don't know what this is, but I do know that J and K are equal. Can I figure out J? How do you figure out a secant angle arc situation? Subtract arcs, divide by 2. So that's 120 minus 30 divided by 2, 90 divided by 2. So this is 45 degrees inside there. We just said J and K are the same. Can you work backwards to figure out that arc, if you know that arc and that?
Yeah.
That's got to be 50. I'm going to call that x degrees. There's your little equation. 140 minus x divided by 2 has to equal 45. In order to do that, that ends up being 50 degrees. Either you got to do that in your head or you've got to separate it and look at it. And last question. This is a typical drag and drop question. And usually you have more choices than what's here. This only had 6 choices. You might have many more. It might look like this. We might might have more numbers in here, maybe 9, 16. The makers of the test like to leave out the powers of 2, just to confuse you. But this one only had all of that. Draw a picture. You've got a diameter. When we had a diameter problem on our quiz, what formulas did you end up using? Midpoint and distance. You got to do midpoint to get the center, which is -3, -1. That means that I'm looking at these two for the left side of the equation. And my radius, if you use the distance formula, turned out to be 5. If the radius is 5, what actually goes here?
25.
25. Do you have a blank spot on the back of your packet? Go to the back of your packet. I said this was 95% of what you needed to know. Here's the other 5%. Draw a circle, and let's put a quadrilateral inside of it. No particular quadrilateral. And here's your rule. This is not true of every quadrilateral, only a quadrilateral that's inscribed in a circle. So if I happen to have 100 there, this has to be 80. The ones directly across from each other. If I have 70 degrees here, what's got to be over here? 110. Just a little rule that comes up every once in a while. The other rule you already know. Suppose we've got a diameter, and I want to trap an inscribed angle inside half of the circle. If that's the diameter, what does that inscribed angle have to be? Because what's being intercepted? How many degrees of an arc? 180. Does it matter where that inscribed angle appears within the half circle? What if I put it over here? Is it still cutting off the same arc? So anywhere inside the half circle, if it's an inscribed angle, you're going to end up with a little right angle inside there. What happens when right angles start showing up? Maybe you've got to deal with the right triangle, which means you got to deal with everything you learned in chapter 7. Anytime right angles show up, you got to start thinking Pythagorean, possibly special right triangles, possibly sine, cosine, and tangent. Whatever works. Those are two little rules that show up every once in a while. If I was preparing for this test on Friday, I would watch some Chapter 10 videos. And Chapter 10 videos are actually at the top of the list on School Fusion. Go to the very top on the right-hand side of School Fusion. And specifically, what we went over last class, Circle Practice 2016 goes over all the answers to this. This thing has two sides to it. Circle angles on one side, length of segments on the other. Everything's answered on here. Did anybody attempt to see that or look at it? Is it available? Does it come up? But there's plenty of other videos in that folder that you can take a look at. For the rest of the time, I'm going to give you your next workbook assignment. You're not going to be doing everything in the next unit because most of it is on your formula sheet. Everybody take out your formula sheets. You're going to be focused on area today.
Yeah,
13 problems on 205 and then 3 problems on each of those pages. This is all workbook. It's all on your formula sheet. If you're looking for the area of the trapezoid, find the trapezoid on your formula sheet. If you're looking at a parallelogram, find a parallelogram.
Is there anything else we're supposed to do? Is this it?
Have you done Circle Palooza? You could work on that.
Like, no other workbook assignments.
For right now. Right now, this is some area problems. Later on, we got some three-dimensional volume problems you're going to do.
What was the original workbook assignment?
The original. Chapter 10?
Yeah.
For Chapter 10 was 10.7, and then there were 2 pages, I think. I think those 2 pages also. All of 10.7, and then 187 and 193, I believe.
It is.
This area work is not going to be on your test. That's the next unit, surface area and volume.
This isn't due before. This isn't due on Friday, right?
No.
Wait, our test is on Friday?
No, so this is what was on board.
The test blueprint, that's your blueprint. Hello? No. The only thing that's not on there, that's on the test, did you take a quiz on circle equations? If you didn't like your circle equation quiz grade, there'll be a section on circle equations. If you do better on that, I change the grade. There's always one in that pouch behind the toolbox.
I'll write that down.
And if you don't know what you're doing, look at the video that it's one of those construction demonstration videos, which you've already watched.
I watched part of it. What did you work?
Yeah. There's always problems.
It does really good.
Oh, rare.
You've got extra credit on this. This was the only thing I pointed out is that you rounded the square root of 80,000. And that's fine. But you could also show it this way. You could simplify the radical to 200 radical 2. And then when you divide by both of them, leave it in that form. You'll want it in this form in algebra 2. But this is good for our class. Good notes.
This is probably